So, just in case anyone missed it, let's backtrack for a second here. What we've done is we've created a new empty script called first person controller. We have attached it to our player, and now we're going to try to move around. First thing we're going to do, actually, before we start the actual typing of our program, we're going to go into the edit screen here. We're going to go into project settings and inputs. And what we're going to see here are all the possible buttons and axes that are already set up in Unity for us. Obviously, we can change all of these, we can add more, we can take some away. But the big ones we're going to start off with are these horizontal and vertical axes, which are mapped to the left, right, up, down arrow keys, and also the WASD keys, which are standard first-person controls. And also, if you're using a joystick or a gamepad to play, it's mapped to the standard joystick as well. So you can right out of the box, you'll be able to move around using a controller. And obviously Unity can even export to things like the Xbox, PlayStation, the Wii, I believe, if you've got those extra packages. So we are going to be looking at the horizontal and vertical axes to make us move. So basically, this is all going to happen in the update. So I'm going to start, again, I'm going to start very, very simple, and I'm probably going to create more variables and sort of more verbosity than you might need to do, but I'm going to try to make it kind of explicit what each step is going to do. So during the update, we are going to be checking to see if we're going to start with the vertical axis because that's going to be our forward and backward movement. We're going to check to see if that is being active. Now, if this were a button, we'd have to do something like if input.getButton and do something with it. If the button is being pushed, then do something. However, the axis, the way it works is the one axis. So in that example, we check, is the forward button is being pushed or is the backward button being pushed? With the axis, we just check the vertical axis, and if it's 0, then nothing's being pushed. If it's in the positive direction, then that's going to be the forward direction. And if it's negative on the axis, which is what happens if you pull back or you hit your backwards key, then it's going to be a negative number. So we don't have to wrap this in an if. We just have to do something like, we'll create some variable here just for. We're going to say, we're going to call forward speed. This is sort of the desired forward speed is going to be equal to input.getAxis vertical. Now, I'm calling it forward speed, but this could be returning a negative number and move it backwards. Now, we're going to have to do a little bit more with it, but just for the sake of argument, we're going to leave it. We're just going to use this as is for now, and then we're going to see what we're going to do with it. We do need to contact our character controller. The character controller is what actually interacts us with the game world. So we're going to be telling the character controller, hey, we want to move this much. So we need to actually grab our character controller that belongs to our player and store it in a variable and then call some functions on that variable. So I'm actually going to, you know what, let's keep it super simple. We'll keep it here for now. So we need to grab a copy of it. So we're going to make a character controller. We're calling it CC, and it's going to be get component character controller. There we go. So we're going to grab our character controller. We're going to store it in a variable called CC, and then we're going to call cc.simpleMove. There's two movement functions. There's a simple move and a move. We're going to start with simple move, then we'll replace it with move afterwards. And simple move wants a vector containing our speed. So, all right, we'll tell you what. We'll create. No, don't autocomplete me when I don't want that. So we can't just give it a float. Our forward speed right now is just a number. We're going to have to create a vector out of this. So that's fine. We'll call vector3 speed equals new vector3. There we go. And our forward movement, I believe, is along the z-axis. And we're going to go and double check over here. We're going to grab our player. If I look at our z-axis and I wiggle it around, yeah, that's our forward and backward movement right there. That's exactly what we want. So our forward speed, so we're going to set our vector to just be 0, 0. We'll look at the others later. The first number is the sort of left-right movement. The second number is an up and down movement. And then the third number is your backwards and forward. So we're going to stick that in there. This will not work like we want. I'm intentionally doing something that's going to be kind of stupid. But this, there we go. We request our forward speed comes from our axis. We use that to create a speed vector. And then we're going to feed that to our character controller using a simple move. And let's see what happens when we hit play. First of all, we should get a nice forward vision right out of our dude. Looks good. then we are going to, apparently we're lagging some more, and I apologize. If it's lagging at this point, there's not going to be anything I can do about it. I think our internet these days is just bad here, so look at it, watch it on YouTube. I'm sorry. So we're going to hit the forward key. I'm going to hit W on my keyboard. Oh, we're going backwards. And if I hit S, we go that way. So our direction is not right, which actually really surprises me. I know why that's happening. Let me unrotate my character, first of all. And let me move my character somewhere else. Let me move my character, say, over here. It's because there's it's because there's like two things that are not set up right yet, which is why we're moving the opposite direction. But there we go. So now I'm not rotated at all. I've just moved to a different place. So I've got something kind of interesting to look at. Now if I hit forward, I move forward. If I hit backwards, I move backwards. Obviously, it's very, very slow. And that's because your axis only goes from, say, -1 to +1. So we're moving at best 1 meter per unit or per second, which is not very fast. So we want to multiply that by some number to make us go faster. And basically, we are just going to take we're going to add a variable to our first-person controller that tells us how fast we actually should be going. So we're going to call it, I don't know, we'll call it actual movement speed. And we're gonna make it public so we can control it in the inspector. We're gonna have it default to maybe 5. And we'll give that a try. So over here, our forward speed is gonna be the axis multiplied by our actual movement speed. Now let's take a look at what that does for us. I think that'll be a much more appropriate speed. Yeah, that feels good. I mean, we're not sprinting necessarily, but that's a much better speed. Good. Now we still can't go left and right, and we still can't turn, but we're getting a little closer. So the left and right is going to be handled basically the same over here, except we're going to call this, we'll call this side speed, right? And we're going to grab the horizontal axis, and we're going to be feeding this into the X of our speed vector, and everything should just work. We should now be able to move side to side. In fact, we can. We can also bump into walls, like I can't go any further this way or that way, and when I try to go forward, we're going to bump into this and not go anywhere. Good. So far, so good. I think actually this is a little bit slow. Let's go. So now we can change the speed over here. Let's, should we double it to a 10? I think that'll be too fast. Actually, that's not bad at all. I kind of like that. All right, 10 meters per second it is. These scenes will probably be choppy on the live stream, unfortunately. We can't look anywhere yet with the mouse. That's the next thing. So, great. We can now move forward and backwards, but obviously a first-person game, you can use your mouse to look left, right, up, and down. So that's the next thing we're going to have to do. Let's go back and take a look at our axes in input. So you can see that there is a mouse X and mouse Y axis already set up for you, which is lovely. So we're going to use that to control our movement. And again, the first approach we're going to take is going to be wrong. I'm intentionally sort of making an incomplete system just to highlight some problems. So we're going to start with the left-right motion. Okay, so at this point we've got, let's go above here. So this is our actual movement, but we're going to want to do the rotation first. So we can do an input.getAxis on our mouse X. So X is the left, right. And we're going to use this to rotate ourselves. Let's stick it in float. So float, we're going to go, I'm going to call it rot X. Stick it in there temporarily. And all we need to do is, we actually don't need to feed the rotation to our character controller. We can just sort of rotate our object. So we're going to use our transform, and we're going to say we're going to rotate, and we can, best way to do it is probably with this version of rotate. We want to rotate around the y-axis because y is straight up, so we're rotating around this sort of axis this way. So we're going to go 0 and rot x 0 like that. Even though it's called, I don't know, rot x, but we're putting it in the y. Maybe we'll just call it like, you know what? We'll call it rot left right. So that's the left-right rotation, as opposed to the up and down. Technically, it's a yaw, right? You've got pitch, you've got roll, and you've got yaw. So this is a yaw that we're doing, but let's not get too involved in that. So now, let's give that a try. There's going to be two things. One, it's going to be very slow, and two, it's not going to affect our movement. You're going to see what I mean in a second. So if I move left to right, yep, indeed, we are looking. I can keep. Actually, it's not terrible speed. It's a little sluggish, but it's not bad. But now, so if I move forward and backward again, it was working just fine here. Great. So I'm moving forward, forward, forward. Good. Now I'm going to turn to the left, and I'm going to hit the forward button again. Well, I'm clearly not going forward anymore. I'm still going in the same direction. I'm going this way. When I do forward and back, I'm moving in this direction. No matter where I'm looking, I'm still moving in that same direction. And that's because the speed that we feed into our character controller here, this is using world coordinates. It's not paying attention to what the rotation of the player is. So what we have to do after we rotate the player, this speed is going to have to be modified by our rotation before we feed it to our character controller. So we're going to take it, again, we're going to go with extra verbose here. We're going to create extra lines, and that's fine, that's fine. Our current speed is actually going to be based on our transforms rotation times the speed. So we're going to rotate our speed to match what our character's actual rotation is. And now, when I go back into here, and I move forward, and then I turn to the left, and then I move forward again, perfect. And that also works with the side-to-side motion, forward and back. There we go, we're going pretty good. I feel like the mouse turning is too damn slow, though. So, and you know what? That's going to vary by people. It's also going to vary greatly by what mouse you're using. Some mice are more sensitive than others, and people are going to want to fine-tune that. Now, we're not going to be building an option screen that'll let people fine-tune that in-game, but we may as well set a public float mouse sensitivity. Wow, there's a lot of syllables in there. And you know what? 5 seems to be working out for the other thing. Let's try and use that. So we're going to multiply our mouse movement by our mouse sensitivity. And let me see how I feel about this. Yeah, I feel like this is better. And by better, I mean way too fast. So it's a public, so we can now modify it over here. We're going to tune it down to, we'll just make it double fast. And maybe I'll feel better about that. Yeah, see, I feel this is okay. But we still don't have an up and down motion. All right, so what do we do about that? Well, the first thing you should know is I always hit Control X as a reflex, or Control S as a reflex to save my changes. So let's go and create a scenes folder, and we're going to call this level 01. Okay, the first thing you should know is that the character controllers are always standing upright. They don't pitch up and down. They don't lean forward and lean backwards in here. If you do want to make sort of a lean effect, you do it entirely in the camera. The way the physics engine works with the character controller is it doesn't actually rotate this way. So when we do our up and down motion, we can't do it like this. We can't rotate the transform of our character controller. Instead, what we want to do is actually change the pitch of the camera. We want to move the camera up and down without affecting our character controller. And there's a few different techniques for doing this. The default Unity way of doing it in their example first-person controller is they have a separate mouse look script on the camera itself, so the camera itself is responding to the mouse, which there's nothing wrong with that. But we're going to try to keep everything in one place for now. So what we're going to do is we will. Okay, so we've done this step. This is our left-right rotation. We're going to do an up-down rotation. Up, down, based on the mouse Y. And then we're going to grab the camera and just rotate it appropriately. And, you know, there's a bunch of different ways we can find the camera. We could create a sort of a placeholder over here where we feed it in from the inspector. We're going to cheat. We know there's only one camera. It's the main camera, so we're just going to grab it directly. So we've got camera.main. Just grab the main camera, grab its transform, and rotate it by, so the roll, everything's gone dark. Everything seems to be back. Okay. The roll is in the up-down, or sorry, the roll is around the x-axis because the x-axis goes through it from the side. So we want to roll around the x-axis. So we're going to feed rot up-down along the x and zero everything else out. And there will be an issue with this as well, but we're going to experience it in just a second. I think this will more or less work as is. Yeah, so first issue is that our axes are inverted. So let's resolve that right away. So basically we want, we're just going to feed it a negative in here. There we go. Up, down, it's great. Now what happens if I go up and up and up and up, and that's not what we want at all. Yeah. So we want to limit how far you can tilt your head back, because realistically, there's, you know, your neck can only go so far. So we're going to create public float, I don't know, what are we going to call it? Up, down, range. We're going to allow, I don't know, let's say 60 degrees. We can tweak that later. So what we want to do is we want to cap the up and down rotation to not be any more than that. Now, right now, we're just feeding in the change to the camera, so we can't do that. We've actually got to, well, there's a few different ways we can do it. A few different ways we can do it. What do I want to do it? How do I want to do it? I want to, I don't know, let's tell you what. We're going to ask the main camera. We're going to ask it, okay, what is your current rotation? Euler angles dot x. Store it as in the float. Current up down is equal to that. And we're going to set it to float desired up down. Again, I wouldn't create all these variables normally, but I want to be explicit. So our desired up down is our current up down minus our rotation. So now if I feed that, well, not into here, I don't want to rotate it by a certain amount. I want to dot rotation dot set, and I want to set the x rotation to be the desired up down. And is this the right set? I'm going to set the rotation this way. Quaternion.Euler. There we go. So we're going to set the desired up, down, 0, 0. So right now, I think this will work as is, except that we can still flip our head upside down. There we go. Flip. Oh, it actually does cap. Right, because of the Euler angle thing. It's still kind of awkward to look straight up. And then you get like kind of weird behavior, and rotating doesn't work out very well. So what we want to do is actually we want to take this desired up down when we want to clamp it to a limit. So we're going to use this, and we're going to say, listen, desired up down, you can be no less than negative up down range and no more than positive up down range, which we set to 60 degrees. And let's see how that feels. There you go. So the up down looking. What have I done? I have done something wrong, and I haven't been able to figure it out here. It's not going up above the 0. Oh. No. Damn it, this was working fine in my test. Let's see what happens here. When in doubt, debug some text. When it goes above 0, it goes back to the negative. I'm screwing something up with my numbers here with the clamp. It's definitely the clamp that's screwing it up. And I'm just being blind to it. That's the problem with doing things live. See, that works. And that works. Oh! Oh, it's looping around to 356 here. All right, so the problem is that I'm just doing this entirely wrong. Stupid Euler angles screwing me up. Hang on, let me open up my my previous work just to double check how I did it there. Euler angles will often come and bite you in the ass. I was using them here because they're more simple for most people to follow, but the problem with simplicity is that, well, just that, it bites you in the ass. How did I do it before? Ah, I believe it's because we need this to be a local rotation. Let's try that. And then I'll explain, if that works, I'll explain what the hell it is. Oh, I don't have the clamp in. I don't think it's gonna work. Is there something just different about the way my camera is positioned this time around? Tell you what, let me grab my existing code, because the problem with doing this on the fly is you make a trillion bajillion different mistakes. So I'm going to, this whole up-down rotation bit, I'm going to get rid of it. I'm going to paste in what I had before. Ah, because I was storing a variable here with my current rotation, starting at 0, modifying that in the positive and negative side. Okay, let me do a quick test to see if this is working before I continue. I apologize for that. There we are. Okay. Yeah, so the problem is I was asking the camera to tell me the current rotation. And Euler angles are your sort of rotation around the x-axis, y-axis, z-axis, and they range from 0 to 356. The problem is when I was asking it for that initial rotation and facing forward at 0, when you go down slightly, you know, you go 1 degree, 2 degree, 3 degree, excellent. When we're facing up slightly, it was wrapping around from 0 to 356, and it's correct. But what I was expecting was more like -1, -2, -3. And the problem is when you ask for something for its rotation in a Euler form, you get those issues quite a bit. So what makes a lot more sense here is I was just storing it locally. I was assuming we start at 0, and I was modifying this number so that I could go. You can tell it rotate to -5, and that will tilt up. You can tell it -5 just fine. But if you set it to -5, and then you turn around and ask it, what are you currently rotated at? It'll say, well, I'm at 355. Which is true when you loop around the circle. But yeah, there you go. So, yeesh. All right, we're past it. Let's move on, right? Yeah, so let's double check that things are working properly. One more time. Look up, look down, great, left, right, and we can move around. And there we go. We're exploring the game world in first-person view. Now, some of you will probably have noticed that there's still a mouse on the screen. Like the mouse pointer is still visible on the screen. And usually you don't want that. Now, the way you eliminate this in a game is by calling a simple function. Maybe we could do it in our start. We could call screen.lockCursor and set it to true. Now, when I start the game, the cursor will disappear. And everything will work great, except it doesn't quite work properly in the editor. The editor treats your mouse slightly different, so that even though the mouse is locked and hidden, if I move over and click, depending on where I'm clicking, well, apparently I'm lying. Oh, maybe it's different when it's full screened. It hadn't occurred to me. Let's not maximize. Hit play. There we go. So now, if I'm not in full screen mode, the mouse still disappears, but when I move the mouse around and I click, it clicks outside the window and the mouse suddenly reappears again and I lose focus and all that. The cursor locking is a little bit weird, only inside the editor and apparently when not maximized.